Here's an example where we're taking the sine of a kind of a complex angle equals 0.21 by first using the interval 0 to 2 pi and then solving for x in there. Okay, so we have sine of pi over 2 times x minus 5 equals 0.21. Okay, well, how do we do this? Well, let's go to the notes. Notice we have one sine function to the first power. So the notes say, let's go back up here, only one type of trig function, first power. Get it alone. Just get it alone, and then take it to the unit circle and get your two answers. Okay, so we will do that. So the first thing, well, it is alone. There's nothing outside of it. So all right, step one. The sine is alone. Alone means there's nothing else over here in front of it or added to the back of it or anything like that. It's alone. So let's go back to our notes again then. So it said take it to the unit circle. It's first power, get it alone, it is alone. Okay, so take it to the unit circle. That's not going to be there. Get the two answers. If the value is not on the unit circle, then see number 3 below. That's where we got to go, number 3. Because the value, that's not going to be 0.21. It's not going to be on the unit circle. So after getting sine, cosine, tangent alone, right, this is using a calculator, then take the inverse sine, cosine, tangent of both sides. But before hitting the inverse, change the number on the other side to be positive, even if it was negative at first. Okay, so they're saying, those notes are saying, we've got to come in here and we got to do sine inverse of this side and sine inverse of that side. It'll cancel it out, right? We're doing sine inverse on both sides so that it'll cancel out that sine, and we'll just get what's left, pi over 2 times x minus 5 equals sine inverse 0. Oh, and make this positive. Of course, it already was positive. Right, positive 0.21. It already was positive, so we didn't have to mess with it there. So we'll bring that down. Pi over 2x minus 5 equals. So let's hit sine inverse on our calculator now. So I'm going to do that sine inverse. Make sure you're in radian mode when you do this. Radian mode. I'm getting 0.2116. It's 5/7, so I'll round it to 6. But I don't think that's the end of the story. Let's go back. It says, realize now that your answer is an angle in the first quadrant. Why? Because we changed the right side number to be positive. All trig functions are positive in the first quadrant. Oh, that's right. Everything's positive in the first. So when we made that positive, we made it first quadrant. We need to find the two quadrants where our answers will be using the all students take calculus, the quadrants where the various trig functions are positive. So let's go back. So in other words, what those notes are saying is that when we do the quadrants here, and we do the 0.2116, this is a first quadrant answer. So we can put that there in the first quadrant. 0.2116. That's how far from 0 in the first quadrant. But remember what we're trying to actually do here. We're trying to find, remember what the original question was back here before we started messing with it. It was sine of some angle is positive. Before I did sine inverse or any messing around, it was sine of some angle is positive. So we got to know, where's sine positive? There's going to be two quadrants. There's always two quadrants. All students take calculus, right? Remember where the trig functions are positive. So we're looking for the two quadrants in which the sine function is positive, right? That's whatever answers we're looking for. Whatever answer in here makes it true. The sine of some answer is positive. So where's the sine positive? Well, first quadrant and second, because all the trig functions are positive in the first and sine is positive in the second. So we're looking for answers in the first and second quadrant. We've already got a first quadrant answer right there. So we'll keep that one. And now we need to find the same answer in the second, which means it's got the same, the same reference angle. So, in other words, this angle right here, 0.2116, they're off the x-axis the same distance. Remember, if you come off the x-axis in any quadrant, if you come off the x-axis the same distance in two different quadrants, you're going to, at that point, you're going to get the exact same trig function, sine, cosine, tangent, etc., except for plus or minus. Otherwise, all the values, sine, cosine, tangent, secant, cosecant, cotan, are going to be the same. Because it's a reference angle. They're the same spot, really, just in a different quadrant. Because they're the same distance off the x-axis. So I got to find what this second angle is exactly. Now, what do I mean is, you might say, well, it's 0.2116. No, 0.2116 is how far off the x-axis in the second quadrant. But the angle, remember, they all start at 0 and go to there. That's, because here's 0. That's the actual angle. Angles are measured from 0. So that's the actual angle. Well, how do you figure that out then? Well, you got to go all the way to, what, pi, and then back up 0.2116. Right? So that's the answer. So the it's going to be pi back up 0.2116. That's the second quadrant answer. So I've got the first quadrant answer, and this will give me the second quadrant answer. Let's crank that. Use your calculator. Take pi minus 0.2116. I'm getting 2.92999, so I'm going to say it's 30, but it's 9230 because it's 2999. So that's the second quadrant answer. Here's the first quadrant answer. So this answer is 0.2116. This one's 2.930. That's the two places where the sign of that crazy inside, we're not done yet, equals positive 0.21. Let me show you that on the notes. Come over to the notes. Here's what I just did. So if your first quadrant, no change. If your second quadrant, pi minus the value. That's what we just did. So I found the two quadrants, first and second, used the first and second formulas. First said do nothing, second said take pi minus. You don't have to memorize that. You can put these right in your notes for the exam. All right, now, having done that, let's go down to number 4. When the inside is not a simple x, do all the normal work according to 1, 2, and 3 above. Then, when you get your answers, set the inside equal to each of the answers and solve for x. So if you got like, so they're showing an example here. Here's 2 answers from this last tangent question right here. And then they said, oh, take those 2 answers, set the inside equal to both those 2 answers, and then solve. So that's what I've got to do. I got to finish this one up now. So let's go back there. So what inside? So this inside right here, this is the inside, right? This is what was inside. See it right here? It's inside the sign. So we just found out. We're just saying that angle, pi over 2 times x minus 5, that angle, that inside is equal to 0.2116, or pi over 2 times x minus 5, that inside is equal to 2.930. So I take those 2 answers, the first and the second answer. First quadrant answer, second quadrant answer. And then you finish it from here. Now, how do I finish it? Well, how do you solve for x? You got to multiply by the reciprocal, 2 over pi. And we get, and same thing here, 2 over pi. 2 over pi. So, take your calculator. And that leaves x minus 5. Take your calculator and multiply 0.2116 times 2, and then divide by pi, right? See that? 0.2116 times 2 divided by pi. That's what you got to do when you have a fraction, right? 0.2116 times 2 divided by, then use your pi button. I'm getting 0.1347. Over here, I'm going to take 2.930 times 2 divided by pi. 2.930 times 2 divided by pi. And I'm getting 1.8653. Last step, we're almost done with this one. Add 5 to both sides. Boom. X is 5.1347 and X is 6.8653. There we go. That was a lot of work, wasn't it? So from the beginning, we had to do sine inverse, positive, get a first quadrant answer, then realize that we needed a first and second quadrant answer because those are the two places where sine is positive. And so we got our two answers, and then we set the inside equal to the two answers and solved from there.